Hi, I'm Alec. I work at Grimshaw and I would like to take you through my work in Intensive 2.1. My research question is currently looking into how reclaimed timber can be upcycled or reused in grid shell structures through the use of parametric design, with a focus on economic and environmental viability. To illustrate the connections between my research and design proposal, I have my conceptual framework diagram. The three key drivers are reclaimed timber, grid shell structures, and of course my building proposal. From this, we can see the links between these initial points and how they influence and relate to each other. Each of these sections then has their own subcategories that they can be broken down into. These subcategories also relate and influence various other subcategories in different sections. Focusing on reclaimed timber, there are many difficulties with the use of the material, including varying dimensions, non-standard finishes and types of timber, and limited organization, making finding a specific dimension and strength rather challenging. This has caused timber to be downcycled, turning a lot of reclaimed timber into non-structural uses. With this in mind, there are a few precedents for the use of reclaimed timber as a structural material. This project, Greenhouse by Estudio Cavernas, was built completely with a reclaimed timber frame. While the structure is very lightweight, it illustrates the possibility of using timber in relatively long lengths for structural means. Similarly, Spring Stream House by Way Architects used reclaimed timber as both a structural and aesthetic choice. This project integrates the aged reclaimed timber with the modern details to create a harmonious space. It must also be addressed that the use of reclaimed timber would be as much a structural choice as it is an aesthetic choice, especially in the case of a grid shell form. This precedent shows that even with the mismatching of dimensions and types of timber, it can be combined to create a unified and aesthetically pleasing appearance. For this intensive, I initially set off focusing to find an efficient solution to digitize reclaimed timber into a material bank so that it can be incorporated more easily into modern design methods. With this in mind, I would like to move on to my design project, which brings together three key elements of my research: sustainability, materiality, and technology. I decided that the Eden project would be an excellent fit as a client for these themes and would be able to further enhance the proposal by providing a known brand that focuses on education. The Eden project's international themes also line up well with the ideology of my proposal. I would be able to create a center that focuses on material resources and their relationship with the natural world. Currently, these are all the Eden Project international locations that have either been built or are ongoing projects. The King's Cross site would provide a unique opportunity for an urban Eden project. However, it would be suitable given the theme of the location would be about material resources. The site that this would be on is the existing Skip Garden site and Lewis Cubitt Park. The proposal aims to maintain the pedestrian link between the two sites, but also displays a continuity over both sides with an open covered space. In section, you can clearly see the various spaces within the project, with a large biome for a botanical garden on Lewis Cubitt Park site and an education and exhibition centre on the Skip Garden site. When reconsidering this design proposal, I found that the Voronoi structure that I had been using gave the idea of flexibility in material length, but in reality gave me 2,593 unique pieces that were all rigid in length. This would ultimately end in a lot of material preparation and material waste. This time spent would make it not an economically viable option. From this development, I shifted my focus to designing a flexible joint that could accommodate differences in material dimensions, making the structure truly flexible. This would consist of a central steel node from which a telescopic joint would be able to extend to adjust to the differences in material availability. This shift in design focus also forced a reconsideration of the structural system. I compared a Voronoi grid with the Delaunay triangulation. Ultimately, these grids use the same points, but have very different relationships with the points in question. However, they both allow for random variation in length, which would still be key to my project. Structurally, the Delaunay triangulation allows for a more efficient structure with fewer timber members due to the fact that all the forces are triangulated in every cell within the form. On average, the Voronoi grid has a shorter timber length, which may seem as beneficial when using reclaimed timber. However, this is a variable in the design process and can be adjusted to suit the material structural performance. These findings have developed the structure over the biome to progress onto using a Delaunay triangulated timber grid with flexible steel joints as the primary structure. A secondary structure would be attached to it, consisting of a matching lightweight aluminium grid to hold the ETFE panels in place. With this in mind, there are still further developments to be made to the structure, notably further optimization of the structural form and steel joints. I would also like to try to find a more sustainable replacement for the ETFE pillows. Finally, here is a section through my proposal showing the live comparison on site of a regular grid shell and my proposed Delaunay triangulated grid shell. In order for this to be a fair comparison of the timber lengths used, the average area of the cells has been designed to the ratio of the area of a square to a triangle. This is down to the primary shapes that can be found in either grid shell. Additionally, the detailed drawings towards the center of the page show the difference in joinery used in either proposal. On the left-hand side of the poster, the flexible design of the steel node is illustrating by changing the timber element in question from one irregular piece of timber to another smaller irregular piece. Thank you for listening.